This is a walkthrough on how to use the pH meter during the Acids and Bases lab. Remember, before any experiment or touching any chemicals, you need to have your safety goggles and gloves on at all times in the lab. The first step to this experiment is the same as every other experiment. Gather your materials. The materials needed are listed above and shown in the video. Before using the pH meter, you need to prime it. Remember that the pH meter is a delicate piece of lab equipment. Remove the cap from the bottle and push it all the way to the top of the meter stick, as shown in the video. It is important that you do not take the cap fully off of the pH meter stick. Doing so may damage the equipment. Place the meter in the large beaker of deionized water. The stick needs to be kept inside this water at all times unless we are using it. In order to prepare your pH meter for calibration, you need to press the button that says Sensors. Next, press Calibrate, then the button to the side. Now you are given the option between 2 and 3 point calibration. Make sure you're on 2 point calibration, then press Calibrate Now. You should be on this screen. Now you're ready to start your calibration. Take the pH meter out of the beaker of the deionized water. Then, wash the bulb at the end of the meter with the bottle full of deionized water. When you're finished with this, gently wipe the end with a Chem wipe. Again, be very careful with your pH meter. This cleaning step will be repeated throughout the experiment whenever changing solution. Once the meter is properly wiped off, place it in the pH 7 buffer solution. Now return to the meter screen. Insert the number 7, wait for the meter to stabilize, and press Keep. Now you're going to repeat the same process but with the pH 4 buffer solution. Clean your pH meter with deionized water, wipe it with a Chem wipe, and place it gently in the pH 4 buffer solution. Return to the screen, type in 4, wait for it to stabilize, and select Keep. And you should be taken to this screen. Now you need to test your calibration to ensure that it's accurate. To do this, clean your pH meter stick again, using the same steps as before, and place it inside the pH 7 buffer solution. The pH meter screen should read a pH of about 7. Wash and wipe the meter off, then place it back in the big beaker of deionized water. If you are lost at any point, refer back to this part of the video. Here, each member of my group can be seen performing pH meter calibrations. Now you are ready for step 3. Step 3 involves finding the unknown pH of a solution. The solutions that we used for this experiment are 0.2 molar hydrochloric acid, 0.2 molar acetic acid, apple juice, and orange juice. Take the pH meter out of the large beaker of deionized water. Wash it, as before, by using the bottle of deionized water to wash off the end bulb, then using a Chem wipe to dry it. Place the meter in the solution of the unknown pH. Once the pH meter has stopped moving digits and settled on a number, that can be recorded as your final pH. Clean off your pH meter and return it to the beaker of deionized water. Record all of these values in your lab notebook. Repeat the steps above for each of your solutions. In this lab, this should be done for a total of 4 times. Here are some example videos for each of the solutions. Here is what my group's results looked like on the pH meter. Make sure these values are written on a neat data table in your lab notebook. Your last step is to clean up your lab area. In your results, you should have noted that even though hydrochloric and acetic acid had the same concentrations, they had different pHs. You might think to yourself, why is this? This is because hydrochloric acid is a strong acid, while acetic acid is a weak acid. The difference between a strong acid and a weak acid is simple. When strong acids are placed in aqueous solutions, they will completely dissociate, while weak acids, for the most part, stay together. Weak acids only have about 5% dissociation. Strong acids also have a much higher hydronium concentration than weak acids. This is why our strong acid has a lower pH.